I am Akshat Mohite, astronaut in training with International Institute of Astronautical Science and the president of National Space Society, USA Mumbai chapter. Like, firstly, we'll be talking on the vision and mission of NASA, specifically Johnson Space Center, because that is a center which deals with astronaut training and purposes. Next, we move on to astronaut training and mentality, the skills which you need to become an astronaut. And lastly, we go on to basic presentation on my project, Project Possum, where I'm a scientist astronaut candidate, and a few things related to hypoxia and G-force training and stuff. So, without wasting any time, let's begin. And I hope I'm audible. So, if I am, just type in yes in the chat. Okay, I assume that I'm audible. So, firstly, let's begin with the vision and mission of NASA. So, talking about the mission of NASA in astronaut training, mostly Johnson Space Center is the one which deals with astronauts, even if you're selected as an ASCAN. So, I am an ASCAN, what that means an astronaut candidate. So, even if you're selected by an ASCAN, you receive a call from Johnson Space Center, and they're like, you're selected to become an astronaut candidate, and to become a full-time astronaut, you need to undergo a few training. So, talking about the mission, we NASA has always been developing new technologies to fly up in space. So after STS, we are just behind other developing technologies. Then SpaceX is one which is also behind this. Next comes the Crew Exploration Vehicle, which took place of shuttle program. Then the ISS, we've been continually behind upgrading ISS, adding new modules to it, like the Soyuz capsule and stuff. So this is a picture wherein you can actually see the Artemis program on the bottom left photograph, and there's the Sunflower Telescope, which you can see. So basically, we are developing a balanced overall program of science exploration and aeronautic consistency with redirection of human spaceflight program. And as we all know, like NASA has been really great in human spaceflight program, as they were the first one to step on the moon, and now they're heading back to moon. The next mission is establishing a lunar return program that we call the mission Artemis, having maximum possible utility for later missions to Mars and beyond. So on the right photograph, you can see the orbit insertion, and above that you have a sample collection on Mars. Then you can see the moon with the satellite, and below it is the Artemis photograph, which was picturized by a 14-year-old guy in America. Education programs. NASA has always been developing new educational programs and grants for students, which is the reason they develop around $250 million every year to motivate students to teach them about aerospace industry and giving them internships and a lot of things. But mostly those are limited to US citizens. But if you're not a US citizen, there are still opportunities that are available for you, about which I'll talk in the later slide. Then comes the educator astronaut program. So selected applicants become a fully qualified permanent member of NASA Astronaut Corps. So it's basically you share your ideas on the next generation explorers, and if you're really successful in creating a revolutionary idea, you get to train as an astronaut, and you can be a full-time astronaut as well. Then comes the education program. Like I said, there are a few programs which you can apply for even without being a US citizen. For example, space settlement design competition. So when I stepped into aerospace industry, my first project was the space settlement design competition. And yeah, of course, it was in 2018 mostly. And yeah, I had won it. Next comes NASA Explorer School, which is limited to US citizens. Then the Digital Learning Network. You have many resources available on NASA.gov, which you can use to learn. Then the Texas Aerospace Scholars Program, you can apply for it, and the Jason Project. out of which maybe three were limited to US citizens, but the others were open to all. For more resources on what we say on educational resources or opportunities, if you want to check, you can just go on nasa.gov and you'll find the correct information that you want. Now coming on to the next presentation that we have, that is on astronaut training. So what do you mean by astronaut training? So I'm, I've listed down around 4 points on astronaut training, but there are around 138 tests and trainings that you need to undergo, out of which these four are for full-time astronauts once they have qualified as an astronaut. For example, the Space Vehicle Mock-up Facility. We have one Space Vehicle Mock-up Facility in Johnson Space Center. It is just to give a feel to the astronauts that how will they be behaving, or what's the the map, the layout of the spacecraft they will be in. So there's a life-sized spacecraft in Johnson Space Center wherein these astronauts just wear their spacesuits or their flight suits, like the one I'm wearing right now, wear their flight suits and roam around in the space vehicle, like of course the mock-up of the space vehicle. Then next comes the KC-135. KC-135 is actually an aircraft that is known as Weightless Wonder Vomit Comet. So why do we use KC-135 is mostly to simulate anti-gravity, like microgravity, for like 20 to 25 seconds to train the astronauts the movements in microgravity. We also carry out some microgravity experiments and campaigns for microbiology and stuff, but then mostly KC-135 is used for astronauts to train to learn the motion in microgravity. The next comes the precision air bearing floor. Um, After reading out this point, I actually remember of a story when I had met like an astronaut, Winston Scott, who used to hold the time, what do we say, who used to hold a record for longest spacewalk. He once told me about the how did precision airbearing floor help him. It's like he had gone to space for a satellite insertion, and the satellite was actually inserted wrongly, and it went around 100 meters above the desired location. So what Winston Scott did is he actually went outside into the space, doing a spacewalk, absolutely, and catching hold of the satellite and bringing it down. So that's the reason we do this. It's like one part of an astronaut's work, maybe including like moving large objects, and I mean really large objects sized like a building or something in space. Then comes the neutral buoyancy laboratory. So again, this is like a swimming pool. I would say this is like a swimming pool in Johnson Space Center, maybe like 64 meters of depth. So this is to practice extravehicular activities or spacewalks. Like astronauts go underwater, they do their spacewalks, and there's a simulated International Space Station where these astronauts can actually repair stuff, use the few instruments, and many more. So it's just to learn how to move up there while deep space exploration. Once you're trained as an astronaut, there's a really low possibility that you actually go to space even after you're selected as an astronaut. So what you do is you work from the ground, like you work on Earth on simulations like Mars simulation, Hera, like MDRS, Mars Desert Research Station. So what we do here, I have recently applied to MDRS, wherein we just go and there are a few centers like the biology center, the botany center, the extravehicular activity center, and of course the pod for us to live in. So as you can see in the second picture on top right, so that's the building wherein we actually stay, and right side to it is the botany center wherein you actually learn how could you try to farm on Mars. So you actually simulate the conditions on Mars, and then you try to cultivate plants or anything up there. And then of course we do spacewalks and stuff. So these simulations actually are real-time simulations. So like Mars and Earth has a transmission delay of around 15 minutes, like approximately 15 minutes, of course. So once you send a message from the MDRS station to Jet Propulsion Laboratory or Ames Research Center, they maintain the 15 minutes of transmission delay and you'll get the answer 15 minutes later. So that's how we try to maintain exactly the same condition as those would be on Mars. Then I would come to like five skills required to be an astronaut: communication, self-care, leadership, followership, team care, group living. So of course, communication. It's like before doing an action, you need to communicate what's your action. You need to discuss over the action so that all the team members know about it. Second comes self-care. Self-care means taking proper rest, working on perfect timings, and not overexerting because astronaut is all about self-care. They need to take their care. Then comes leadership or followership. This is one of the most important points. So if you're like a captain or commander of the spaceship, you need to lead your teammates, or if you're a part of the team, you need to follow the rules and regulations and the instructions given to you. Team care. Team care is like you need to respect each other's positions, responsibilities, and act as a family. And that's what is actually group living as well. Like you don't grow up together like friends, but then you need to behave like you guys know each other since long because you're gonna be up there in space, stranded all alone in a group of three, and it's only you. So you need to have really great communication and group living skills. So once I'm, done with this thing, I'd rather go to a basic presentation. As you know, we have kept this seminar for 30 minutes. So I'd like to quickly go through this. So the basic question which I receive, like most of the time, is like how to get into NASA or any other space agency. So there's no kind of hack or like just shortcut to get into NASA or ISRO or European Space Agency. It requires these five things to get into this specific space organization. The most important is the citizenship. So if you're a citizen of India, you can apply for ISRO. If you're an American citizen, you can join NASA. If you're an European citizen, you can join ESA and likewise. Next comes qualifications. Of course, like many times people just mail me regarding what course should I take up or, like what should I study, where should I study to become an astronaut. So I would just recommend one thing. If you're a bachelor student, take up mechanical engineering or aerospace engineering if you can. Um, and if you're a master's student, then rather just go for astronautical engineering or aeronautical engineering, and that's how you'll be perfectly qualified to get in as an astronaut. Researchers. So what do I mean by researchers is you need to have research papers published. Like today, my age is 18, but like I have around seven research papers published and two patents on my name. So that's how you actually work out to get your name above. Like you want to fly with eagles and not with a pigeon. So you need to have something unique in yourself. Then comes creative thinking. By this point, I actually mean like space is a lot undiscovered. So you need to think creatively. So that way you can actually find out something which is not yet discovered and write up a research paper over it, prove it, and yeah, you're done. And lastly comes critical problem solving. So this, firstly, when I used to present this presentation, I used to just have like 4 points. But when I spoke with astronaut Winston Scott, he told me to add in the fifth point, that is critical problem solving. So, like the story I told you about the satellite, which was um, wrongly inserted into some other orbit, and he had to pull the satellite down to the desired location. So it was all related to critical problem solving on basic instances. Coming on to Project Possum, the first mission I entered in as a scientist astronaut candidate, Project Possum. So what does Possum means? Possum is basically polar suborbital science in upper mesosphere. This might sound a lot technical, I know. Basically, this is a mission wherein we study the mesosphere and do noctilucent cloud tomography. So, what is tomography? Tomography is basically clicking pictures and photographs of a certain type of cloud, which we call noctilucent clouds, because they're really white in color and you can't see through. So, this is mostly important in re-entry of space vehicles. So if your space vehicle is entering back into the atmosphere of Earth, and once it's in the mesosphere, you can't actually have a look or have a view at the spacecraft when it is near the noctilucent clouds, and that's what we do. We go up there, like of course we don't touch the mesosphere with those normal kind of jets, but then we try to attain such heights that we can actually use the red cam and click pictures of mesosphere and study how these are created and how can the problem be tackled. So that's basically my mission. This is the mission patch. It's written Boston. So yeah, then comes hypoxia. To be an astronaut, there are not only four tests that you need to give. Like I told, there are more than 100 tests that you need to pass, and hypoxia is one of them. So in hypoxia, you're actually put inside a chamber, a pressurized chamber, and it takes you at an altitude of 25,000 feet, of course, by altering the pressure inside the chamber, and it checks the oxygen supply in your body. And in the right picture, in the second picture, you can see my certification of SAMI, which certifies me, for my hypoxia training and aviation psych physiology training. The hypoxia is a condition in which body or a region of the body is deprived of adequate oxygen supply at tissue level at an altitude of 25,000 feet or above. So my oxygen level at 20,000 or 25,000 feet was like 91%, which was really, really good. And that's the reason I got this license from SAMI. Now, this slide shows my G-force training. So I personally have taken up to 6Gs. It's not visible on the sheet, but then I'll show you one video once I'm done with this. So I personally have taken around 6Gs of force, and this is what you get once you're in flight. A single piece of paper inside an envelope, and once you're up in the sky, you just open this paper and you see what are the manuals that you need to do. Like you need to make a 360-degree turn to the right, then a 360-degree turn to the left, at 2Gs, and the same at 3Gs. Then you reach around 4G, like a total 360 turn, and then you go into microgravity, and again the same, and then you go to GY and negative G. Okay, so it sounds pretty much technical, but then if there are a few aerospace engineers out there, they might be pretty much well versed with this kind of aviation diagram. Okay, then, any questions, just hit me up on the email ID, and you can follow me on Instagram. My Instagram ID is Cosmo Akshat, Cosmo Akshat, and I'm open to questions. So, any questions, just hit me up. Thank you very much. Stay home, stay safe.